Hey, welcome back to RamZland. Today I want to talk to you a little bit about gyroscopic precession and the conservation of angular momentum. Check this out. I should probably start by talking about vectors. A vector is really anything in physics that has direction. A good example would be force and momentum. Take, for instance, this car. If I apply a force to this side of the car, it has momentum in that direction. Whereas if I apply force in this direction, the car has momentum in this direction. Remember that momentum is just mass times velocity. But what if the force that I'm applying is not necessarily to the left or to the right? What if I'm applying a rotational force? This is what's called torque, and torque creates angular momentum. Check this out. So I can find the vector of the torque by using the right hand rule. So if I hold up my right hand and I curl my fingers in the direction of the torque that I'm applying, the downward force, and I hold out my thumb, then I can see that the direction of this angular momentum is going to go in this direction. Check it out. There it goes. I'm here with Shayara and Esther, and another way to show the conservation of angular momentum is having Esther stand on this rotating platform. So when she changes the axis of the wheel, that momentum will transfer to her body and her whole body will turn. So Shayara, give that a spin. Okay, and then Esther, change the axis of the wheel. There you go, now you're turning. Good job, Esther. It really pulls on your arms, doesn't it? Oh, we can see her rotating on the platform below. Conservation of angular momentum. Good job.